Okay? Now, on number 2, we have this picture right here, and we have a question underneath. Find the value of x that will make this quadrilateral a parallelogram. Okay? Well, this picture looks very similar to the last picture we had on number 1 because we have diagonals involved. But this time we're talking about maybe doing some algebra to help us find the value of x. We already know that this and this are equal. This segment and this segment are both equal. So in order for it to be a parallelogram, we would have to think that this and this are also equal. Because if they're equal, then what way have we just shown? That's right. We've shown the way that we just talked about. Way number 5. Show that the diagonals bisect each other. So all we're going to do is we're going to set 4x minus 7 and 2x equal to each other. Because once we do that, we have proven that those are indeed equal, and we have proven that the quadrilateral is indeed a parallelogram. So let's set the steps. 4x minus 7 equals 2x. Now, let's do the simple algebra. Okay, first step, add 7. Scratch that. Why do I scratch that? Because 4x and 2x, they both have an x, so I don't need to move the 7. I really should move one of these x's. So let's move the 4x. By subtract. Since this 4x is positive, I want to subtract. I'm going to cancel that out, zero it out, bring down my equal sign. This is negative 7. Bring that down. What's 2 minus 4? Negative 2. So it'll be negative 2x. So we have negative 7 equals negative 2x. Finally, we're going to get rid of the number beside x by dividing negative 2 to both sides. I'm going to cancel that out. I'm going to get x on this side, and a negative over a negative is a what? A positive. I can hear you. 7 over 2 equals x. Now, if you wanted to keep it like that, that is okay. Because I told you before that having fractions instead of decimals is perfectly okay. But if you want to make a decimal, how much would 7 have to be? Yep. Let's see here. We're going around the room here, aren't we? 3.5 equals x. So either one of these is acceptable. Now, what does this 3.5 equals x mean? What it means is that's the only way that this is that this quadrilateral is indeed a parallelogram. Okay? If x equals anything else besides 3.5, based on this picture, then this shape is not a parallelogram. Okay? So that's the reason for this exercise. We had to find out what it took to make this shape a parallelogram. Okay? So that's what we had to do. Okay? Hopefully you have that. Okay? All right, let's go to number 3. In number 3 is kind of a wordy statement, so I'll give you a moment to kind of write it down. And I'll read it aloud as you're trying to write it down. In quadrilateral GHJK, the measure of angle G is 55 degrees. The measure of angle H is 125 degrees. And the measure of angle J is 55 degrees. We need to find the measure of angle K, then say which way to show that GHJK is indeed a parallelogram. Okay. All right. So what you have here is you have 3 angles given to you out of 4, and you just need to find the 4th angle, and then that will help us find the that this statement is true, that GHJK is indeed a parallelogram. Now, what you can do is I'm gonna draw it. You can draw it, and I'm gonna draw it just like how I've been drawing the other 2 parallelograms. So I'm just gonna draw below like this. Okay. And let's see here. Since this is kind of an acute angle, well, this is an acute angle as opposed to this being an obtuse angle, I'm going to go ahead and label G right here, then go around the shape counterclockwise, or clockwise actually, with these angles, with these letters. So H is right here, J is right here, K is right there. What do we know in this shape? We know that G is 55 degrees, so I'm going to put 55 degrees right there. We know that angle H is 125 degrees. And we know that angle J is 55 degrees. So the question is, what is angle K? All right? And then think about which way we need to use so that we can prove that the shape here is indeed a parallelogram. Well, if this is 55 and this is 55, we already know that these two angles right here are what to each other? They are congruent. G and J are both opposite angles, and they are congruent. So it goes to show that if I have this for angle H, then what should I have there for angle K? You got it. 125 degrees. So angle H, angle K are both opposite angles, and they're congruent. So that proves that the shape here is indeed a parallelogram. So let's sum up this problem. We need to find angle K, the measure of angle K. So we'll say that the measure of angle K is 125 degrees. Now we have to go back and answer the rest of the question. Then we have to say which way we can show that GHJK is indeed a parallelogram. And we just proved it, because we know that H and K are opposite angles. So do you remember which way, based on the 5 ways I told you, that shows that a quadrilateral is a parallelogram that we're going to use here? Yes. We're going to use way number, way number 3. Way number 3, remember, states that opposite angles are congruent. Okay? Some of y'all probably beat me to the punch there. Okay? Couldn't remember my order. But anyway, way number 3, opposite angles are congruent. So this is how we have to answer this question. All right? Now, just like we did on the last question, if this angle measure had been anything else besides 125, this would not be a parallelogram. Okay? Yes, 55 degrees and 55 degrees are opposite, but keep in mind that the way was that both pairs of opposite angles are congruent. So I need to also write that down here. And remember, this is both pairs. This has to work for both pairs. Okay? So if I can get both pairs of opposite angles to be congruent, then I've proven that the shape is indeed a parallelogram. So if this had been 124, this had been 128, anything besides 125, this would not have even been a parallelogram. Okay? Now, we have one more example we're going to show you using a coordinate graph. And let's get to that right now.